A very good morning to all of you. Myself Amandeep Kaur. I am here to present my topic on process management function. Let's start with the job scheduling. Means how the jobs are scheduled and why this scheduling need to be. The first purpose of the process management is job scheduling. In multi-programming system or multitasking operating system means where we have to execute more than one function at the same time. More than one application is executed at one time to increase the efficiency of the system so that two work can be done at one time. It is the responsibility of operating system to effectively and equally allocate the processor time between the multiple jobs so that the waiting time of a particular job does not exceed a desired limit. This is called a job scheduling. This means that for increasing the efficiency of your computer system or your system, we have to go for multi-programming or multitasking. Means we are executing the multiple tasks at the same time. Then it is the responsibility of the operating system. It is the one of the characteristics of the operating system to allocate the time equally between the multiple jobs so that the waiting time of one particular job does not exceed the desired limit. So this is all about what we are going to discussing today, that how this should be done. For that we have, first of all, we should know what is a process. Obviously a process is a program in execution. Means process is that program which are written by the user and are waiting for the CPU time so that it can be executed. And the components of the processes are object program to be executed, means what you have write the text, that is program text, as we say in the Unix it is called program text, or source program what you have written, that is the one of the component of process. The input data to be processed, then what is the data in between your file, that is interactively or by your means, and result it produce, that what should the output you are expecting. Then resources required by the programs, for example files, etc. Then PCB, process control block, the containing the state of the process in execution. This PCB contain the state, either it is waiting state, either it is ready state, either it is not valid state, etc. Then there is a clear distinction between a program and a process. Please don't intermingle the program with the process, because program is a static entity made up of source program language statements that define process behavior when executed on a set of data. But process is a dynamic entity. Dynamic means it is not static, it is not the same at all the way, because that execute a program on a particular set of data using resources allocated by the system. Two or more processes could execute the same program, each using its own data and resources. Then we will see how it works. The process is, we have the object program, means what should you are expecting, then we have the data which is going to be executed, then process control block, resources, then the abstract machine environment. In order to execute a process need an abstract machine, means we need a machine to execute the data. Machine obviously is your computer system that have CPU, the processor who execute the, means it makes the environment, we said the abstract machine environment to manage its use of the resources. PCB is required to map the environment state on the physical machine state, means that is the part of the PCB is the location of the current instruction in the object program that is being executed. This is a useful information to load the PC of the processor whenever the processor gain control of the processor, and the operating system keeps a process description of each processes. Here you can see the components of process. This is the object program. This object program is any source code. It is when executed, then the output is obtained. The data on which we have to be the program is executed, then PCB which keep the location or which keep the record of the state of the and the other resources you are needed to execute that. Here in this slide we will see how the program is executing. Each execution of a program generates a process that is executed, and it is non-reentrant. That means the data and the code, text, address space of each processor users are different, and the reentrant means the data address space are unique for each processes, and the code text is the same for all the processes. Means the one is the data which is going to be the executed, and other is the code in which the values are inserted and we execute the code. And it has the inter-process relationship which include competition. Processes are trying to get access to different resources of the system. Therefore, a protection between the process is necessary. And there is a cooperation because sometimes the processes need to communicate between themselves and exchange information, and synchronization is needed. Now, what are the function of process manager functions? Means how it will allocate the time, how the CPU scheduling is done, which is allocating or differentiating the time between each processes. The functions include, the first is obviously the CPU sharing, and how to implement this CPU sharing means how CPU will decide what the data is executed first, what the data is executed before that. It must allocate resources to processes in conformance with certain policies. Certain policies like first come first serve, round robin, priority basis, shortest job first. Means these are certain policies which CPU has to be used for making the things possible. Then implement process synchronization and inter-process communication means which process is executed first, which later on, which after that, it all will be decided by the process manager. Then there is the implementation of deadlock strategies, means if two processes come along and they are intermingled with each other, which process is going to be first, which process is going to be second, then there is there any deadlock? Deadlock is a state when one process is using the resources which is needed by the other process also. So, here are some mechanisms which we are going to discuss today, that how these deadlock will be avoided, how the CPU share its time, what are the policies it is adopted to share, etc., and how it is implement the CPU sharing. So, here you see the process manager. It's diametrically it is showing that what are the program it has to be executed. First there is a one program, it is converted into process, it is assumed as a process. Here you see in the diagram, it is the program, this program is become the process, and this process goes to the abstract computing environment. This computing environment includes our computer system, our CPU, which have the protection means security features, process description means what type of work is to be done, deadlock, synchronization, scheduler means CPU is allocated the scheduling capabilities, means what data is executed first, what after that, which is the longest one, which is the shortest one, who has the big priority, who has the less priority, etc. And there is a resources required to execute the processes, etc. And here we see the file manager, device manager, means all are hardware which are required to execute your process. Here you see how this scheduling is to be done. Here you can see some of the states are showing here, like there is a new state, means when the one process come to execute in the CPU or in your PC, you first admit the data that you have to execute this. Then if all the resources are available that if this process can be executed, then we said it is the ready state. Then there is a, if there is no any interrupt, CPU is running, then it is a running state. If some resources are required which is not available, then it is in the waiting state. If all the done thing is done, then it is terminated state. We will discuss all this in detail. First of all, we will see the CPU scheduling. What is CPU scheduling? Always want to have CPU working, means obviously if the processes have to be executed, we need the central processing unit. We need some system that can execute our task. Then usually many processes in the ready state, because if all the processes getting their all the resources, then it is in the ready state. Then ready to run on CPU. Ready state means ready to run on the CPU and focusing on a single CPU here. And obviously there is only one CPU, that is why we need the scheduling. If the one single CPU is doing the things or going to execute the processes, then it should, the CPU should allocating any strategies, should need the strategy for allocating CPU time, selecting next process to run, deciding what happens after a process complete a system call or completes input output, and the short term scheduling. कहने का मतलब ये है कि ਜਦੋਂ ਸਾਡੇ ਕੋਲ ਬਹੁਤ ਸਾਰੇ ਪ੍ਰੋਸੈਸਿਸ ਹੁੰਦੇ ਹੈ, ਅਸੀਂ ਉਹਨਾਂ ਨੂੰ ਐਗਜ਼ੀਕਿਊਟ ਕਰਵਾਉਣਾ ਹੈ CPU ਤੋਂ, ਤਾਂ CPU ਨੂੰ ज़्यादा ਜਦੋਂ ਮਲਟੀਪਲ ਟਾਸਕ ਨੂੰ ਅਸੀਂ ਐਗਜ਼ੀਕਿਊਟ ਕਰਵਾਉਣਾ ਹੈਗਾ, ਉਹਦੇ ਵਾਸਤੇ ਸਾਨੂੰ ਪਹਿਲਾਂ ਤਾਂ CPU ਦੀ ਸ਼ਡਿਊਲਿੰਗ ਕਰਨੀ ਪੈਣੀ ਹੈ ਕਿ CPU ਵਿਲ ਡਿਸਾਈਡ ਉਹਨੇ ਕਿ ਪਹਿਲਾਂ ਕਿਹੜਾ ਪ੍ਰੋਗਰਾਮ ਐਗਜ਼ੀਕਿਊਟ ਕਰਨਾ ਹੈ, ਬਾਅਦ ਚੋਂ ਕਿਹੜਾ ਪ੍ਰੋਗਰਾਮ ਐਗਜ਼ੀਕਿਊਟ ਕਰਨਾ, ਉਹਦੇ ਵਾਸਤੇ ਉਹਨੂੰ ਇੱਕ ਸਟ੍ਰੈਟਜੀਜ਼ ਚਾਹੀਦੀਆਂ ਹੁੰਦੀਆਂ ਨੇ, and this strategies is called CPU scheduling. Here you see the CPU burst and the input output burst alteration. This means what the CPU does. CPU the jada time hai that will be divided into two, CPU burst and input output burst. मतलब एक time ਹੁੰਦਾ है ਜਿਹੜਾ input ਲੈਣ ਵਾਸਤੇ ਅਸੀਂ use ਕਰਨਾ ਹੈ ਤੇ output ਵਾਸਤੇ use ਕਰਨਾ ਹੈ, ਤੇ ਇੱਕ ਜਿਹੜਾ CPU ਨੇ ਜਿਹੜਾ ਆਪਣਾ process करना, जो CPU अपना काम करता है, that we say the CPU burst. जो system ने input सानू लेनी है या output show करनी है, that is known as the input output burst. Here you see load, store, add, store and read from file. मतलब when load some data, add some data and read the data from the file, we said it is the CPU burst. When the system is waiting for input output system, means waiting for the resources, we said input output burst. Here then CPU store, increments, index, write to the file, means when the and we are doing the modification on the files, we said it is the CPU burst, and when the waiting for the input output, we said it is the input output burst. In general, the most program that short CPU burst. What happened when input output burst occur? What is the process state at that time? When the system need the input output units, then what happen? What is that state known to be? Here you see when can CPU scheduling occur. Scheduling occur when there is an interrupt, when there is a waiting. Here you see when the new process come and admitted for the CPU that this process want to be executed. This is the new state, this process is going to be executed. Then it is admitted to the CPU. Then CPU will decide all the resources which are required to execute this process are available. If those processes are available, then we said it is the ready state. If those resources are not available, then then we keep that file into the waiting state. If there is any interrupt occur and if there is any waiting, then we keep the processes in the waiting. If the process is ready, suppose after that the processes got its resources, then the scheduler dispatch the process into the running state. means running state is occur when the process got its all the resources which are needed to execute. ਜਦੋਂ execute ਕਰਨ ਨੂੰ ਉਹਨੂੰ ਸਾਰੇ resources ਮਿਲ ਜਾਣਗੇ, then the process is in the running state. Then when the process is run, executed successfully, then we exit and terminated. But until the processor does not meet its resources, it is in the waiting and this interrupt state. This is that's why the scheduling need to be, because when multiple new processes are coming along, then we need to be in the waiting state, and the CPU need to be scheduled so that which process is to be done first, which process to be executed after that. So here you see, when does or when can scheduling occur, means what are the states when scheduling is needed. The first is when a process terminates. When one process terminates, the other come, the CPU need to be scheduled. Second, when a process switches from running to waiting state, means the process is executed, but somehow the due to any other process execution, the processing of the one scheduled is to be halted, then it is in the waiting state. Third is when a processor switches from running to ready state, then this also scheduling need to be. When a timer interrupts occur, this is occur when the timer interrupts occur. And the fourth is when a processor switches from waiting state to ready state, means completion of input output. So we are revising, when a process when does scheduling occur? When a processor terminates, when a process switches from running to waiting state, means ਜਦੋਂ ਇੱਕ process ने running to waiting state ਤੇ ਚਲੇ ਜਾਣਾ, we need the scheduling. When a processor switches from running to ready state, then we also need the scheduling. When a processor switches from waiting state to ready state, then we also need the scheduling. And here the case 1 and 2 means when the process terminate and when the from running to switches to the waiting state, we said non-preemptive scheduling. And when from waiting state to running state and running to ready state, then we said it is the preemptive. Actually the four stages are preemptive type of scheduling, but 1 and 2 is the non-preemptive type of scheduling. Now, when do batch, multiprogramming and multitasking system do scheduling? Multiprogramming is when multiple programs are executed on one program, one system, and multitasking is when one system is executing the number of tasks at the same time. We said it is the multitasking. And when does this types of scheduling is required? When obviously when a process terminates, it is called a one batch. When the process switches from running to waiting state, we said it is the multi-programming. Here you see, one process terminate and one process switches from running to waiting state. We said it is the multi-programming, means multiple programs are running at the same time. And when the process switches from running to ready state and when the process switches from waiting state to ready state, we said it is the multitasking or time sharing. Please note down these points. When the process terminates, it is a one batch. When a process switches from running to waiting state, it is said to be multi-programming. And when a process switches from running to ready state and waiting state to ready state, it is said to be multitasking or multiple sharing. Now the scheduling performance criteria, the first is CPU utilization, means how much CPU is utilized, the percentage of time that CPU is busy over some period of time, then we said it is the CPU utilization. Throughput is number of jobs completed per unit time, means how many jobs are completed at one particular time is known as throughput. Then comes the turnaround time. The time interval from submission of the process until completion of the process, means when the process starts its execution until it completes its execution, we said it turnaround time. Then comes the waiting time. Some of the time period spent not running, means in the ready queue, but they are waiting for their turns, we said it is the waiting time. Then comes the response time, the time from submission until first output input, or approximate estimate by the time from submission until first access to the CPU is known as response time. Now we will discuss the CPU scheduling algorithm, means what are the strategies we are taking care, or CPU is going to use for deciding what the process is to be executed first and what other. The first is first come first serve, means complete the job in the order of arrival. As the jobs are coming, they are doing that. The second is shortest job first, means with that process which complete the job with shortest next CPU burst is to be executed first. Then comes the priority basis, processing have the priority, and allocate CPU to process with highest priority is to be processed very first. Then comes the round robin, each process gets a small unit of time on CPU. It is called to be the, we said we divide the CPU time into the slices and allocated that time to the processes, then it is said to be the round robin. Here you see the first come first serve, how it works. The ready queue data structure is a FIFO structure, that is first in first out. For example, draw the Gantt chart for it. Compute the average waiting time from the process. Suppose we have the 5 processes, namely P1, P2, P3, P4 and P5, and the time needed for its execution is P1 has 20, P2 has 12, P3 has 8, P4 has 16 and P5 has 4. Please draw it. Then this is the CPU burst time, that CPU time units are in the milliseconds, and the waiting time, the time period spent in the ready queue. It also calculate the average waiting time across processes. Assume zero context switch time. So here you see the P1 gets the 20, P2 will be finished at 32, P3 at 40, P4 at 56 and P5 at 60. What is the waiting time? For P1, for P2, P2 has 0 waiting time, P1 has 0 waiting time, P2 has 20 waiting time, P3 has 32 waiting time, P1 has 0, P2 is 20, P3 is 32, P4 is 40 and P5 has the waiting time 56, and the average wait time is, I will sum it, add it and divide by 5, and that is 29.6. Please note it. Then what is the advantage of this first come first serve? The relatively it is simple algorithm. As the processes are coming, we are executing it, and it has the disadvantage that those processes which come in the later on or the last, they have the long waiting time. So this is the disadvantage of FCFS. Then there is the shortest job first. In this, the job will with the shortest or next CPU burst time is to be selected. The example is same. P1 has 20, P2 12, P3 8, P4 15 and P5 4. This is the time needed to execute the task P1, P2 and until P5. And we are making the Gantt chart for it. Here you see. Now the shortest is P5, which need the 5 units, we will execute it first. Then after P3, which need time until 12. P2 has 24, P4 has 40 and P1 is 60. And the waiting time is P1 have only 40, P2 12, P3 4, P4 24 and P5 0. And here you see the average time is only 16. So obviously FCFS scheduling has average time 29.6 and the SJF shortest job first has the average time only 16. So, which one is better? Obviously, shortest job first. Then we will discuss the advantages of STF, probably shortest average waiting time. But we have to actually implement this? Can we actually implement this? No, because as the process is coming, we cannot identify that which is the shortest, which is the longest. If the longest one come first, we have to so each one have their own advantages and disadvantages. So these are the some of the disadvantage. It requires future knowledge, but many estimates may estimate or predicted knowledge. How to estimate the predict the future? So this is the how we will predict because with the these formulas and time, which is not easy. Say alpha is this. Next come the priority scheduling. Priority scheduling is have to decide on numbering scheme 0 for the highest or lowest, means we have to assign the priority for each processes. Priorities can be internal, set according to operating system factors. It can be external, set as user policies. It can be static, fixed for the duration of the processes. It can be dynamic, changing during processes. And for example, the function of amount of CPU uses, the length of the time, etc. But there is a one starvation problem. What is the starvation problem? It is the priority scheduling algorithms can suffer from starvation, means the unidentified waiting for CPU access. In a heavily loaded system, a steady stream of higher priority process can result in how priority process never receive the CPU time. It can strive for the CPU time. One solution is aging. Gradually increases the priority of the process that wait for the long time, means we can assign the most highest priority to that function which is waiting from a long time. So here, which CPU scheduling algorithm can be preemptive? First come first serve is a non-preemptive. Shortest job first can be either it can be a preemptive, it can be a non-preemptive. Choice when a new shorter job arrives and can preempt current job or not. The priority can be either, it can be both. Choice when the process priority is changing or when a higher priority process arrives. Now the priority inversion. What is priority inversion? We will have to question on the homework. You will have to find what is the priority inversion. The next scheduling algorithm is round robin scheduling. This round robin scheduling technique is used in time sharing or multitasking system. Typically kind of scheduling algorithm is a contemporary general purpose operating system, and the method is give each process a unit of time. We set the time slice or quantum of the execution on CPU. Then move to next process in the ready queue. Continue until all processes completed. It necessarily preemptive because required uses of time interrupt. Time quantum typically between 10 to 100 milliseconds. So we will give allot the time from 10 to 100 milliseconds for each processes. And the example is the same example I have taken, like CPU burst time is for P1 is 20, 12, P3 8, P4 16 and 4 for the P5, and draw the Gantt chart for this. Here you see we will divide the time slice to each. The P1 got 4, P2 8, P3, and you see the P5 completes at 25, P3 completes at 32, P2 completes at 44, P4 completes at 55 and P1 is completed at the 60. So waiting time for the P1 is 60 minus 20 is 40, P2 is 44 minus 12. When 60 is when the process complete, and 20 is when the process is start, as same in the P2 case. 44 is when the P2 completes, and 12 is when the P2 start. In the same way, we can calculate the waiting time for each process, and the average time is 30.4. So